Hi, welcome to our talk, Pwned in Translation from Subtitles to Remote Code Execution. We're Omer and Omri. We're security researchers at Checkpoint, and let's begin. So what we're going to present today is a new concept. It's a new attack vector. We call it Subtitles drive-by attack. And it's important to remember that this is not about the vulnerabilities, even though we have plenty of those. This is about the notion that subtitles are considered dangerous. So let's back up a little bit. This is how we used to watch movies at the local cinema. But as technology evolved, the internet became faster and we got lazier, the movies entered our living room. It could be a laptop, a smart TV, a Raspberry Pi. The streaming options are endless. Now, designed with ease of use in mind, they take care of everything for us. They pull all the metadata, the trailers, thumbnails, plot info, and subtitles. These are the statistics of daily downloads from one of the main repositories, Open Subtitles, ranging from 7 million up to 10 million downloads a day. It's definitely a big thing. Obviously, subtitles are used for non-native English speakers, like most of us, but not only. And to convey the necessity of subtitles, we'll use the power of memes. They're used when you're watching foreign films, TV shows, like pretentious French films. They're used for convenience in case there are any sort of time limitations. And they're used in Guy Ritchie's movies. Sometimes they also provide critical notes for the hearing impaired, as you can see. But they usually have a lot more than just text display. Let's explore the subtitles landscape. We all know SRT. Subrip text, it supports a very basic set of HTML tags like bold, italic, and so forth. There's also the sub format that stands for subviewer. It supports basic formatting like color and fonts. Sometimes sub actually stands for MP-sub that supports none of the above. And at different occasions, sub can also stand for micro-DVD subtitles. This sub supports formatting, color schemes, font configurations, subtitles location, and different character sets. Another common format is the Substation Alpha. It's a bit more sophisticated. It supports predefined style names, fonts, complex color palettes, outlines, shadows, alignments, margin, alpha level, and encodings. But it gets even more impressive as we move on to advanced Substation Alpha. Now, ASS contains all the functionality of SSA with some interesting additions. The ASS format supports scaling, angle shifting, binary image embedding, binary font embedding, drawing. Yeah, this is us actually drawing a small dinosaur as part of the subtitles in a movie. And the specification even mentions system commands. This allows executing a specified program as background task, and we truly hope no one ever implemented this bizarre feature. But back to our subtitles, there are actually shitload of subtitle formats. All in all, during our research, we encountered more than 25 subtitle formats. Some are binary, some are textual, none are well documented. So we asked ourselves, can the unregulated nature of the subtitle madness be exploited? Our first target was the most notorious streaming platform we know, Popcorn Time. The multi-platform Netflix for pirates integrated a deadly combination of a BitTorrent client, a video player, and endless scraping capabilities under a very friendly user interface. Now, this beautiful WebKit-powered interface is packed with movie information and metadata. It presents trailers, plot summaries, cast information, cover photos, IMDb ratings, and much more. But the way it does it so elegantly beautiful is by using a platform that supports web technologies. Technologies as HTML5, CSS3, and JavaScript built on top of a node engine. The two main frameworks that allow such beauty are NWJS and Electron. Both are multi-platform, utilizing Chromium, and supports external plugins. Okay, so we know they look good, but are they vulnerable to anything? Well, these underlying technologies are very interesting from an attacker's perspective, especially because what might be considered as a weak vulnerabilities, at least in bug bounty programs such as XSS, can actually result in remote code execution, because Node.js is essentially a JavaScript engine with server-side capabilities. And all you need to do in Node.js in order to pop a calculator is use this code, which imports the child process library and uses its exec function with calc as the argument. We'll talk about this in a minute. But back to popcorn time. To make life even easier, subtitles are being fetched automatically for both the user convenience and the attackers. The question remains, can this behavior be exploited? Well, behind the scenes, Popcorn Time uses Open Subtitles as their sole subtitle provider, with over 4 million subtitled entries and a very convenient API. It is an extremely popular repository. This API does not only allow for easy search and download as you would have expected from a subtitle-related API, it even helps you find the right subtitle for your movie and release. We'll dive deeper into that process a bit later. Now, gaining some knowledge about Popcorn Time infrastructure, let's see how subtitles make the way from file download to the screen. Well, our journey begins as soon as the user starts playing a movie. Popcorn Time downloads the subtitles and converts whatever format it gets to an SRT timecode. After conversion, it is passed to the update display function. This function will create an HTML span containing the subtitles text. Well, since the SRT format supports HTML tags, and this is a WebKit, they didn't need to make any implementation to support HTML. It's obviously built with HTML to its core. But perhaps we can write other things than HTML, like JavaScript, unsanitized JavaScript, built on top of a WebKit application. Well, let's try this simple one. This is how a standard SRT file looks like. We already know it supports HTML tags. But what if we try to load an image that doesn't exist and provide it with the onError attribute? XSS 101, we know the onError attribute can run JavaScript. So brace yourself. Yeah. Okay, we got our first vulnerability. We managed to make subtitles pop a message box. But that's not good enough. Let's try something a bit more advanced. What if instead of the alert, we write a code to clean things up, remove the revealing icon of the broken image, and append our malicious payload to the page, which would dynamically create a script loaded from a remote host, our host. Well, needless to say, just as we showed earlier, Evil.js will utilize the Node.js capabilities of the framework to run a process. Let's take a look. The user opens Popcorn Time, chooses his favorite movie. loads the subtitles he wants. Now we can see the attacker's point of view. And we get a remote shell. The victim is now owned by the attacker. Okay, cool. So we know how to create malicious subtitles for popcorn time, which is great. But how would a user get our subtitles? So let's talk a little about the subtitles supply chain. With an average of 8 million daily downloads, Open Subtitles is the world's largest online community for subtitles. Their extensive API is widely integrated into many other video players. And among the basic functions you would expect to find in such APIs, upload and download, it has the smart search capability. This smart search is essentially a chained function requesting all relevant subtitles from the server, sort and rank them, and returning the best matching subtitle for your movie. Let's take a look. Looking at the request of the smart search, we can see the only argument passed is IMDb ID, along with the required language, in this case, all languages. While the response contains all matching subtitles to the IMDb ID. So obviously, Popcorn Time automatically loads the subtitles with the highest rank. But what determines the rank? Skimming through the documentation, we bumped into this ranking scheme. We can see that the score is based on 5 criteria: movie hash, tag, IMDb ID, FPS, and something called others. Also, extra points are credited for being an admin or a trusted partner. But since the only argument sent by Popcorn Time is the IMDb ID, if we would have wanted our malicious subtitles to be chosen by the API, the maximum points we could have get is 5, us being anonymous uploaders. A bit discouraged by the documentation and scores seen in other popular movies, which were higher than 5, we turned to the source code of Open Subtitles, Open Subtitles API. We learned valuable lessons. If you truly want to break something, reading the documentation is not the way to go, because the source code revealed an undocumented behavior. The match tags function is called either way, but what is match tags? Match tags function will break the file name of the movie and the subtitles to tags. And a tag is basically an isolated word or numbers of the file name, which are usually separated by dots and dashes. Then a short loop checks how many shared tags does the subtitle file name and the movie file name has in common. After that, a weird formula is taking place. The amount of shared tags is divided by the number of movie tags and multiplied by a max score of 7, which is a constant number. It is the maximum score that can be assigned in case of full compatibility between the two file names. Let's see a demonstration of how the function behaves. And let's assume this is the movie file name streamed by Popcorn Time. We can easily do that by using a sniffer. And this is the name of a candidate subtitles file name. The code first splits the movie file name into tags, and then it splits the subtitle file name. The match tags function then checks how many shared tags they have, 3 in this case. The API then goes to its formula, which is shared tags, 3 as we just saw, divided by tags in the movie file name, 8, we see that on the left, multiplied by the max score, which is a constant number of 7. This gives us the final score of 2. Well, this behavior makes it trivial to achieve full compatibility. All we have to do is name our malicious subtitles identically to the movie. In this case, we get full compatibility plus the IMDb ID 5 points we already had, and we get 12 points. But wait, there's more. These are the recommended subtitle score for some of the most popular content available online. Deadpool, Frozen, Inception, Snowden, and Westworld Season 1, Episode 1. This graph shows the score of the 7 most popular languages in the world, displaying their average and highest score. Scanning automatically through a bunch of popular subtitles, we noticed that the highest score of a subtitle got was 14, while the average is 10. So at this point, we've showed that we can consistently achieve a solid score of 12, higher than the average, but still we're unsatisfied. So as you recall, extra points are credited for being a trusted, a ranked user. So crawling Open Subtitles website, we found this table. Apparently, all it takes to become a gold member and earn extra 3 points is 101 uploads. So we signed to Open Subtitles, and 4 minutes later and 40 lines of Python, we were golden. So we wrote a small script that gets the score of all subtitles available for a given movie. As you can see, our subtitle has the highest score of 15. Well, what this basically means that given any movie, we can force your player to load our crafted malicious subtitles and exploit your machine. So let's see what else we can do with it. Omer.
All right, hi. So moving on, our next target, called Kodi, which is formerly known as XBMC, is an award-winning open source cross-platform, and it is available in all major platforms in 72 languages, and it is used by over 40 million people. It is probably the most common media center software around. And it is also a really popular combination with Raspberry Pis and Smart TV, making it kind of interesting from an attacker's perspective. So this is the screen that is displayed when you want to download subtitles using Kodi. This is the request that is being sent, and we recognize it as we're already pretty familiar with the Open Subtitles API structure. And this is the code that is actually fetching those subtitles. First, the search subtitle function is called, and the response is being saved into a variable called search data. Then a for loop iterates over these results, extracting the information from them and formats them into a string called URL. Then each of these created URL are sent into a function called add directory item, which in turn results in this screen. And now the user can select his desired subtitle and just continue watching the movie. So let's back up a little bit and focus on that URL string for a moment. Since Open Subtitle is obviously open, the attacker has complete control over the file name that is being received under the value of subfilename. And here we see how each of those 4 keys in item data are formatted into the URL string. So given the fact that the attacker completely controls the file name, what can he do with it? So usually the file name will be something like this, subtitle file name SRT. But what if afterwards we append the ampersand sign, and then we add something like this? This would effectively overwrite the original link and ID parameters, which we originally didn't have any control over, simply because this is a string and it is being parsed by a very basic split function. Well, how does this help us? because once the user chooses his subtitles, the download function is called. And the arguments to that download function are derived from that URL string. And these are the arguments we can now control: the ID and the link. So how does this function behave? First, it uses the Open Subtitle API to try and download the subtitle based on the ID given to it. But the really interesting part is what happens when it fails, if the ID does not exist. Then the not result branch would be taken. And it downloads a zip file from the link given to it. So by changing the ID to something that doesn't really exist, such as -123, and overwriting the link to point to a zip file stored on our servers, we can force Kodi to download a remote zip file. And after the download, the zip file is sent to the function xbmc extract. Now, instead of using any standard library for zip extraction, Kodi decided to implement their own, which, as we all know, is usually a great idea, right? So downloading an arbitrary zip file from the internet is definitely careless, but chaining this behavior with another vulnerability we found in Kodi's extraction method made it lethal. Let's see. What Kodi built-in extract archive function does is building a file path based on the folder names inside the archive. But what Kodi neglected to handle are folder names that contains 2 dots. So that's right, we have directory traversal here. So all we have to do is to create a zip file that contains dots as folder names, and then we can make the extraction just create any Python script. We choose to overwrite the add-on itself, which will be immediately called again, thus executing our code. This resulted in this CVE and our second vulnerability for today. Let's see that in action. User opens Kodi, searches for his favorite film. All right, now we open the subtitle menu we discussed earlier. And due to our fantastic rating of subtitles, all of the 3, I think, top entries would be our malicious subtitles. So you can choose whatever you like. Again, we see the attacker's perspective. We get a reverse shell and tiny VNC. Now we have complete control over the victim's computer. So moving on to the next victim. While Popcorn Time definitely marked the rise of streaming apps, being temporarily shut down by the MPAA, it left users looking for answers. And Strem.io offered just that. Like Popcorn Time, it is designed with ease of use in mind, and actually has quite similar user interface. Interestingly enough, Strem.io shares a few characteristics with Popcorn Time under the hood. Most importantly for us, it is also a WebKit-based application, and you guessed it right, it also uses Open Subtitle as its subtitle provider. So we thought that would be easy, and we tried the same trick that we used on Popcorn Time. You can actually see the broken image icon at the bottom, but no message box appeared, so that didn't really work. And apparently, our JavaScript has been sanitized, and it was time to dig a little deeper. So Strem.io code is archived as an ASR file, which is a simple tar-like format that just concatenates all the files together, but without any compression. So we used the Node.js library to extract it, and we got all the necessary files we needed in order to inspect the code. Extracting the source code and prettifying it, we realized that any text added to screen is passed through Angular sanitize. And the sanitize service will parse an HTML and only allow for safe and whitelisted markup and attributes to survive, thus sterilizing the string so it contains no scripting expression or dangerous attributes. So while having to use only static HTML tags really limited our options, this called for a really creative solution. So if you've ever used Strem.io, you must be familiar with the Support Us pop-up banner. Now, we know that we can use static HTML tags, right? So what if we present this same image of the Support Us banner using an image tag, but we surround it with an href tag? This way, there's no script to be sanitized once the user would click like he always does in order to close it. But when he will click it again, he will be redirected to our malicious JavaScript with the same code shown earlier. So let's take a look at this demo. And we get a calc. There's no fancy reverse shell here, just a nice calc. So realizing the disastrous potential of Subtitle as an attack vector, we move on. And I'm pretty sure that there is no need to introduce our next target, because with over 180 million users, VLC is definitely one of the most common media players out there. And it is open source and available in almost any platform imaginable. So at this point, Yanai Livne, also a member of our team, right here in the crowd, joined us, and much of the work shown here is due to his contribution. So VLC, in fact, is a complete multimedia framework, just like DirectShow or GStreamer, where you can load the plugins and modules dynamically, depending on the necessity. So the core framework is just used to do the wiring between the different modules and the media processing. So whether it's from inputs like files or network streams to outputs, whether they're audio or video, on a screen or on a network, it uses modules to do most of the work at every stage, like various demuxers, decoders, and filters. Now, being described even by its own authors as a very popular but quite large and complex piece of software, we're pretty confident that subtitles-related vulnerabilities do exist. So let's find them. Textual subtitles are parsed by VLC in a demuxer called subtitles.c. And these are all the supported formats and their respective parsing function. As you can see, that's quite a lot. And the demuxer only job is to parse the different timing conventions of each format and then send every subtitle to its decoder. Now, other than SSA and ASS that Omri discussed earlier, that are decoded by a dedicated library, all other formats are decoded by VLC's own decoder, subsdec. So again, rolling their own decoder, that's a pretty bad decision, and inevitably things will go wrong. So this subsdec takes every subtitle, here we see an example with SRT, and parses its text field. It then creates two versions of it. The first is a plain text version with all tags and attributes and styling stripped off, and this would be used in case later rendering will fail. And the second, more feature-rich version is referred to as the HTML subtitle. And HTML subtitle will contain all the fancy styling attributes, such as fonts and alignments, etc. And after being decoded, subtitles are sent to the final stage of rendering. So going over the VLC subtitle-related code, we immediately noticed a lot of parsing is being done using raw pointers instead of just the built-in string functions. And this is generally a bad idea. Let's see an example of it. So again, this is how a basic SRT subtitle will look like. And this code uses PSD subtitle variable to parse the subtitle 1 byte at a time. In this case, the code just identified the HTML font tag. And it then moved on to consuming its attributes, the face attribute in this case. So the decoder will continue reading from the buffer until a closing bracket is met. What this means is that in case the closing bracket is missing, the parser would just keep on reading, resulting in an out-of-bound read vulnerability that was assigned with this CVE. So while auditing the code manually, we also started fuzzing VLC for subtitles-related vulnerabilities. And our weapon of choice was the brilliant AFL. And this security-oriented fuzzer employs compile time, instrumentation, and genetic algorithms to discover new internal states and trigger edge cases in the targeted binary. So getting the fuzz command right was a bit tricky. We created a corpus and also created a dictionary. But our main obstacle was the fact that our fuzzing server had no GUI. So we overcame this challenge by using the transcode functionality. This option will make VLC convert a movie from one codec to another while attaching the subtitles but displaying nothing. So that was perfect for us. And so what is the corpus? A corpus is a set of initial test cases comprising of valid files that represents the protocol or functionality that is being fuzzed. And we plan to start with SRT and ASS simply as these were the formats that we researched first. And so for our corpus, we cherry-picked various of those files that incorporated some of the more exotic features we discussed earlier. So this is the basic time convention of SRT format. And we intended on adding more formats to the corpus as we go along, but the amazing thing is that we didn't need to. AFL just blindly build valid subtitle files of different formats with just zero knowledge. In this case, he created the JSS format all by itself. And this is a great demonstration of one of AFL strengths, that is assembly-level instrumentation, because the odds of a traditional fuzzer to just randomly flip bits and bytes to take one timing convention of SRT and turn it into a JSS time convention are extremely low. However, through assembly-level instrumentation, AFL notices how minor mutation trigger slightly different code path every time, and it uses those as a seed for further fuzzing rounds. So great job, AFL. And it didn't take it too long to lock down on a vulnerable function called parse JSS. And JSS stands for JCO subscript files. This is a very flexible format, allowing for some really interesting functionality. It relies heavily on directives. Directives is a series of character codes strung together, and they determine the subtitle's position and font and color and so forth. They come in two forms. First, there's the global directive that will affect all lines below it in the text file, and there's the inline directive affecting only the current line. And these are some of the more common directives used in JSS. T, which stands for timer, is used to set the time resolution, 100 units a second in this case. S, that stands for shift, will cause all events to occur 20 time units sooner than usual. F, that will send font number 3. You can actually predefine up to 10 fonts, I think, to font number 18. And for an inline directive, this is the example. It will display the following text using color palette number 2, which can also be user-defined. So yes, it's really weird, and VLC doesn't do a great job in parsing those. So looking at the basic parse.jss function, we can see that VLC, again, iterates over the lines with a while loop, again, 1 byte at a time. It parses timecodes and a handful of supported directives, and the text itself, obviously. And the crash found by AFL was due to an out-of-bound read while trying to skip some of the unsupported directives. So here and throughout, PSD text is a pointer to a null terminated string allocated on the heap. And the code assumes a directive is always followed by a space. Therefore, it would look for this space to indicate the end of a directive. In case the directive is written without any following spaces, this while loop will skip the null by terminator, overrunning the buffer. And that was assigned with this CVE. And this got our attention to the parse.js function. And we soon manually found another 2 out-of-bound read issues in parsing of the directives that actually were supported. So moving on with the JSS format, we stumbled upon the font and the color directives. As you can see, the code includes a double increment to skip from the directive right to the argument. But in case a directive didn't contain any argument to follow it, meaning it ended with a null termination, this double increment just skipped the null terminator. But let's see how this code is combined within the bigger picture. So this entire chunk of code is within a while loop. And here's our double increment right there. And skipping the null byte, we actually remain in the while loop, copying from PSD text to PSD text 2. That's over there. And however, PSD text 2 is only the length of PSD text plus 1. So while we are reading out of buffer at one place, we're also writing out of buffer at another. And this sixth vulnerability, a heap-based overflow, actually allowed us to ultimately run arbitrary code on the machine. So at another case, you can see that when the parsing loop reaches a null terminator in a specific case, for some reason, it intentionally decides to skip it, making this number 7 vulnerability. So let's talk about exploitability for a second. These bugs are definitely not trivial to exploit. However, it is interesting to note that the main binary of VLC is not ASLR, or PIDE as it's called in Linux. And by design, the main binary is just wiring libVLC core and the plugins, but it does offer some quite useful gadgets. So for example, this gadget that will find the symbol of whatever string is in RSI and then call it with RBX as an argument, which is quite useful, right? So for a quick POC, we had one of the team members, Yanai, to develop an exploit for this vulnerability, for the moment ignoring ASLR. And we get a calc. Cool. So let's sum up this research. We discussed the complete madness that is the subtitle landscape. We saw we had over 25 subtitle formats, none of them well documented, without any dedicated library, and zero standardization between players. We were able to gain full remote code execution on 4 major platforms. Now, please note that these were the only platforms that we researched. So this means that there are other platforms out there probably vulnerable to subtitle drive-by attacks. We're also able to manipulate the subtitle repository ranking scheme, thus taking control completely over the entire subtitle supply chain. And this means that what we just presented is a brand new malware delivery system, completely transparent to the user, requiring no user interaction, which in our case included over 220 million potential victims. Now, the notion of attackers being able to upload malicious subtitles to a major repository and forcing the different players to download them should now be taken into account as a new valid attack vector and prepare the security vendors and industry to mitigate it. And now, Omri and myself made a little bonus for you. our audience, we curated our favorite calc popping scenes into a beautiful compilation. Actually, on the first draft of this talk, this bonus was titled 2 Girls, 1 Calc, but that almost got us fired, so we had to tone it down a little bit. Here it is. Enjoy.
People sometimes make mistakes.
Yes, they do.
How can it talk?
It's not a real voice. This box just interprets signals from the computer and turns them into sound.
Shall we play a game?
Oh. Yeah, weird, isn't it?
What is it?
Is that what I think it is?
Mm-hmm.
It's cute.
But damn it, what is it?
You wanna play games? Come on. Okay. You wanna play what? Okay. Say hello to my little friend. You wanna play what? Okay. Yeah. Okay, Kalana? Huh? You want more?
And that's just a sample of the exciting exploits ahead in our first feature motion picture.
Holy memoranda, folks. Make a note not to miss it.
Good thinking, Robin.
Thank you.
有没有朋友对这个 talk 有想问问题的？请说。你用英文讲好了。
Hi, this is a wonderful research and it's shocking and crazy. And
Thank you.
yes, so I want to ask one really important question. How did the vendors patch those things? Cross-site scripting has existed for a long time, lots of bypassing and things like that. How did they fix it? And do you guys think it's safe to do the patches? Thanks.
Okay, so obviously each platform had different vulnerabilities. Some had XSS, some had logical bugs, some had memory corruptions. We contacted all the vendors according to the 90 days industry standard of responsible disclosure. Some were more responsive than others, but at the end, everyone patched their software. So these bugs are solved.
Are they safely solved?
Those specific bugs are, yeah. There could be others.
So basically, the WebKit-based players, they are still vulnerable if you can get any JavaScript running.
Okay, so no, there are actually mitigations built into the WebKits. They were not activated at some cases. There are some sort of mitigations, but currently these bugs aren't supposed to work anymore.
Okay.
I think. Hope
Okay.
so.
OK
Okay, thanks.
OK，我想统计一下，有多少人用 VCL player 在你 laptop？ VLC. How many people using the VLC on your laptop? Oh, you can. So it's vulnerable.
I want
we
to.
are in danger.
Are you still using it? Are you still using it?
Not as much. Stop watching movies.
好，还有没有什么朋友有问题的？我知道你们平常看的片子都没什么字幕啦，应该还好哈。有没有问题？不要害羞。没有，再说。
So there are like 4 vendors you've investigated. Which one of them do you think is has the most sense of security written in their code? So you would recommend us on a safety.
Yeah. I don't know about the most safe code, but definitely VLC, I think, responded to us within very few minutes. And they were really active and involved and us checking their patches and wondering whether if it's secure. And I do know that VLC version 3 is currently being developed. I don't think it's still like the main version right now, but they took the time to make sure that these vulnerabilities are not in the following versions.
好，有没有除了 Henry 之外的问题？对，请说。
Hello, thank you for your wonderful presentation. I was wondering because there are a lot of online streaming services, so you can like watch movies in your browser, kind of like YouTube, and some of those services also load subtitles. So, did you guys look into whether those services have vulnerabilities? Thank you.
No, actually we haven't, and since it's running within your browser, I assume it doesn't have any server-side capabilities like we've seen in the Node.js. So your Chrome can just easily pop a calc. Well, it's not that easy. But no, we didn't look at, these are the only platforms that we researched, but we encourage you to have a look. It's an interesting field.
好，那我们这次来，对，请说。你可以用一下那个麦克风。
Okay. Yes. Yeah, I want to ask that if there are so many extensions of formats outside, yes, and which one is the one you would best recommend to use? Because everything seems to have the vulnerability.
Well, usually it's not at your choice. You just download the subtitles offered for you. Yeah, as we showed, sometimes the subtitles are being downloaded automatically, so you don't even have the option to choose. I don't think there's a better subtitle format than others. I mean, some do provide interesting capabilities, but it all comes down to how the code parses the subtitles and if it has any vulnerabilities at the parsing process.
So would you recommend that if I strip everything away from like the format and then just leave the basic text?
I think that would be safer.
Probably would be safer, although you might not want to do that because SRT does support basic HTML. Sometimes you do want bold or italic vulnerabilities. I don't know. It's a big discussion of how the vulnerability can be triggered, but usually that would be like a first step that might get you out of most dangerous vulnerabilities.
Okay, thank you.
好，我们是请说。
I wonder, does Open Subtitles provide better review mechanism if there's some malicious user to upload the evil subtitles to on their websites? Thank you.
So actually, Open Subtitles doesn't have any vulnerabilities per se within their mechanism. But actually, once we contacted them and told them about it, they asked us if we would like to advertise something, like put some like a textual message within the subtitle, and we thought it's pretty funny because we can just put our exploit into into all the subtitles. But no, I'm not aware of any change that they did, and I'm not really sure if they should because it's not a vulnerability. You know, it's just like a ranking mechanism. It's a ranking scheme.
Okay, any question? 好，我们这场非常精彩哦，因为对不起，请说。
I think if from your research, if we convert all the subtitle SRT, all the subtitle file into the web VTT format, do you think that this is a good way to avoid all the attack?
Well, obviously, less complex formats are prone to less vulnerabilities, right? And WebVTT is simpler than ASS or SSA. But again, I can tell you, like, they can be vulnerabilities within the parsing of the timing convention, which you have no control over, it's just timing. But these are the vulnerabilities that we took a look, and this entire research was just like a concept to present how subtitles can be dangerous. So I'm not saying that these are the only vulnerabilities that do exist.
还有没有我漏看的？有没有要问问题？不然我们时间差不多了，因为我不想耽误大家吃午餐的时间。那这场 talk 非常精彩，我很少在一个 talk 里面看到这么多新的 CV 一起出现，各种组合，非常可怕，而且让我们知道原来看片子也是很危险的一件事情。好，让我们再热烈掌声谢谢 Omer 跟 Omri， 谢谢 ，Thank you。